So dear friends and dear students, we are going to see now today the set theory. Okay, and actually it has been established and it has been introduced by the G scientist name is G Cantor is a scientist name who has actually established the concept of the set theory. He defined a set of collection of definite and distinguishable objects. So we have got a set, okay, and this set is there, and these sets are distinguishable and definite. So it should be a definite one. So it has got some definition. It's a definite, and also the you can say that the another one is a distinguishable. So it has to be distinguishable. Okay, so suppose this is set A, okay, and collection of definite, and then the set 3 forms the basis of several other fields of study like accounting theory, and we will see into the graph theory also. But what is the definition of set? Set is an ordered collection of different elements. So set is a ordered collection, okay, ordered collection of the different elements. A set can be written explicitly by listing its element using sets bracket if the order of element is changed. Okay, the set of all positive numbers. So example is set of all positive numbers. Second example is a set of all singers. You can say set of all programmers. Okay, so you can also say that the set of the all lowercase letters. So representation of the two ways are being there. So one is a representation which we can do it of the set is called as a roster representation, and another one is a representation as a builder representation. So builder representation, and this is first one, and this is the second one. Let us see now. The set is represented by the listing of all the elements. Compromising it, the elements are enclosed within the braces and separated by the commas. Suppose a set of ovals is there. So ovals in English. Can you write it? English that is alphabet. So that is A in the bracket. So A, E, I, O, and U. Okay, the set of odd numbers. You can say also the set of even numbers, also set of odd numbers you can take. So we are taking a set of odd numbers. Suppose if I take a B, then you can say the set of odd number is 1, 3, 5, 7, 9 in this way. Okay, set builder notation. So this is actually type of the notation is called as the roster notations. So you can say this is called as a roster notation. So this is called as a roster notation. What is a builder notation? So builder notation is, here we will see that is described by the element A is there. So element A, okay, we can say the element A is a set where there is a element X such that somewhere it is writing like this and somewhere it is writing like this also. So the P of X, something is operated on that, and that is called as a P. So if I say that set is, you can take this, how can you represent this in the builder form? So you can say that X is A is a nothing but the X such that, or you can say like this also, such that X is a oval like this. X is a oval in a English alphabet. X is a oval in English alphabet. Okay, English set. So also you can say that suppose I have got another example that is for the builder notation. That is, you can say that B is the set of the odd number which is less than 10. How can I say it? How can I say that is B is nothing but I got a 1, 3. This is, if you take now as it is 1, 3, 5, 7, and 9. So this is a less than 10 and greater than 1. How can I show that in the form of builder notations? So b is equal to x such that, okay, so 1 is greater than x or equal to x and less than 10. So, and you can also say that, so if I do the modulus of 2, then it should not be equal to 0. Okay, if an x is element of a sub. So this is about the notation of the roster. Okay, the builder notations which we have seen, definition of set we have seen it, and then we'll go forward to the belongs to the elements which are belongs to the set. So we have got the set. Once again I will tell it to you. This is a set A, okay, and you can see now here this is a set A. So, or you can say set X. This is a set S, suppose, instead of saying A, if you say S. So X belongs to X means it may be said to be as X in S. Okay. So there are some elements. This is X which is belong. Suppose Y is here. So Y, you cannot say that this is like this. So we should have to write it. X does not belong to S, or it is not in a yes. So example is that if I take S, the previous example was 1, 1.2, and then 0.7 like this, any example, or 2, anything you can take it, and which belongs to, so we can say that 1 belongs to S, but we cannot say that 1.8 does not belong to S. So, okay, some important sets are there, so which we have studied in your 12th standard. So n is a natural number set, z is an integer set, which is positive and negative. Another one is a z plus integer. Second one is a q, that is called the set of all rational numbers. R is a set of all real numbers, and W is the whole numbers set. So what is a cardinality? So let us see the concept of the cardinality. Cardinality. What is a cardinality? So cardinality of a set S is denoted by you can say that this is like this. S is the number of elements of the set. So the number of elements which are present in this set, that is called as the cardinality. So the number of element, if the set has the infinite numbers are many numbers are there, so you can say that the cardinality is a finite number. Suppose we will take the example. So example is, suppose if I take the cardinality of this 1, 2, 4, 5. What is cardinality of this? Cardinality of this nothing but 1, 2, 3, 4. Okay. So if I say that X cardinality is equal to Y modulus, meaning is that the elements in X are the same. The elements of number of elements in elements are Y. The number of elements exist. There exists a bijective function f from X to Y. If I say X and greater than Y, that is cardinality, meaning is that number of elements in the X is less than the number of elements in Y, and it is equal to 1. And if I say the X less than Y, same thing happens here. So the X is less than Y elements. So the sets X and Y. Now let us see now the types of the sets, which is the types of the sets. So types of the sets are definite number of the elements. So it's called as the finite sets. So finite set. First is the finite set. Okay. So this is a finite set. So we can say the example by your builder type of the notations. You can say that S is equal to X. This is element of X, any element of X, such that X belongs to capital N, and it should be equal to, you can say that greater than 10 is nothing but the previous example which we have taken it in the last explanation, that is the X is greater than 10. So this is number of elements are finite. So what will be happening is that, so it is an odd number and X is less than N and less than 10 will be there. So it is not so that is a natural number is less than 10 numbers. That is 1, 2, 3, 4, 5 up to the 10 only. So, okay. So and then we can say that it belongs to the NL. What is a subset now? Subset. So there are a finite set and there is an infinite set also. Okay. One thing I want to tell it to you. So less than 10, if you say that less than 10, so less than 10, this is called as the 9. Okay, 1 to 9, 1 to 9. This is a natural number n, and this is a natural number less than 10. So 1, 2, 3 up to the 9. So we can say how we got a 9 numbers. That's why it is 9 is nothing but the finite numbers. So what is infinite one? Infinite set is nothing but if I got s and then x and then x belongs to n, and if I say that x is greater than 10, okay, so what will happen is that x belongs to n, so greater than 10 the elements is going to 11, 12 like this, so up to the infinity. So it is called as an infinite set. So two sets are there, infinite set and finite set. These are the two types of the sets. Now let us see now what is a subset. What is a subset? Types of the subsets also. You can say. Now suppose I have got a set A. This is a set A, and it is a set of a cricketer. So if I say that these are the elements, and these three elements are bowler. Okay, these three elements are a batsman. What is the meaning of this now? If I take this set as a B, this set as a C, then I must say that A is a, so I must say that B is a subset of A and C is a subset of A. So the number of elements which are present in C is less than the number of elements present in A. Okay, so you can see now like this. Now what is actually, this is actually subset. This is a subset. What is a proper subset? The subset of a but not equal to A. That is very important. The set X is a proper subset of Y. Okay, or you can say that set X is a proper subset of Y written as X proper subset of Y. What is the meaning that is that if every element of X is an element of set A, every element of X is an element of set Y, you can say that. So the every element of X, okay, is a element of a Y. Okay, so and also you can say cardinality of X should be less than cardinality of Y. That's why, because every elements of X is the element of Y, meaning is that number of elements in a Y may be a larger, So this set may be larger, this set may be smaller. Okay. So the example, you can say that if I take the example, that is our example, so you can take set that we got number of players are there, 1 to the up to the 11 players are there, and if I say that capital Y is equal to the 1 number player and 2 number player, so I must say that Y is a proper set of X. Okay, so proper set of X. Okay, so and this is X has at least one element in a more than set. So you can say now at least one element is more. It has got a nevertheless it has got a nearly how many elements are more? 9 elements are more. Okay, 9 elements are more. Okay, now what is a universal set? And we'll see what is a universal set. Universal set, we can define that is universal set. Okay, the universal set See, we define U as a universal set. Okay, so this is universal set. Okay, as a set of all elements on the earth, set of all animals on the earth. In this case, set of mammals is a subset of U. So set of mammals is a subset of universe. A set of fishes is a subset of universe. Insects are subset of universe also, and so on. So empty set, it's very simple example. Empty set, it's very simple. There is nothing is there in the element, and nothing element is there in the set. So this is empty. So this element, it should be set is finite, but even the we can have to say that the cardinality of that set. Suppose A is there and nothing is there in this. Okay, so we can say that this is a phi. So the cardinality is nothing but the 0. So you can say that null. This is also called as the null set. This is also called as a null set. So example is that if I say that S is equal to X and then X belongs to N, and if I say that X is greater than 7 and less than 8, then what will happen is that it will be a phi, isn't it? So because there is no element in between 7 and 8, because N is a natural number, so it is a natural number, that is integer number. So suppose this is another type of set. Another type of set is called a singleton set, or we can say also that unit set. So what is the singleton test? That is set is there. Singleton set or the unit set contains only one element at all. So the single set is denoted by a capital S like this, only one element. So this is only one element is there. So how can I say that? So if I say that S is equal to, in a builder notation, such that X belongs to capital N, where 7 less than X and 9. What is the meaning of that? I have got only one element in a set, that is called as a 8. So I can say that S has got an element, that is 8. Okay. What is equal set? So these are all the types of the sets, and you have to remember this, because all these are the basic concepts of the set theory, and any examination you will be getting confused with all this set. Suppose I got a equal. What is the meaning of equal set? Okay, set A is there, that is 1, 2, 3. Sorry, 3. So this is 3. This is 3, and set is 3, 2, 1. So whether it is going to be equal? Yes, because the elements of a set A is an element of set B. So elements, whatever the elements are there, are the same in the elements of B. So I must say that these are the set which is called as the equal set. This is called as equal set. So what is equivalent set? Equivalent means, only remember this is the difference. Equal set means the number which are there in A and number which are there in B will be the same. The elements must be same. For equivalent set, the number of elements in the two sets or three sets will be same. What is that? Cardinality should be the same. So that is called as a equivalent set. So if I say that A is equal to 1, 2, 3 and B is equal to, suppose I say that 12, 13 and 14, then what I will say that this is called as equivalent, because number of elements are the same, that is 3. Number of elements 3. So it is called as a cardinality. So cardinality B is equal to cardinality A is equal to B, and then it is a 3. So You can see now this is called as the, so these are the types of set, and